For example 6, we are going to graph a piecewise function. And a piecewise function consists of more than one equation that is graphed on the same coordinate plane or same piece of graph paper. So my function actually contains three separate equations. One is y equals x plus 1, y equals 5, and y equals x squared minus 6. Now I know the equation of y equals x plus 1 is a slope-intercept form equation. It is linear and it makes a straight line and has some kind of slope. So I know this first equation should look like that on my graph paper. And I'm looking at the second part of my piecewise and it says y equals 5. So I know that that is going to make me a horizontal line at a y value of 5. And then also I have my last equation in my piecewise that is y equals x squared minus 6. And I know an x squared, a positive x squared, is going to make a parabola that is opening upward. So ahead of time, I know what my graphs should look like on the graph paper. I just need to make sure that I'm putting those graphs in the correct location. If you have a piecewise function, you are only graphing your equation in the part of the graph paper that they tell you to. The domain or x coordinates that I can use in my ordered pairs for my function x plus 1 contain x values that are less than -1. So this part of my piecewise tells me where on that graph paper I should graph it. So I need to be to the left of -1, and I'm going to section off my graph paper right where that spot is. And this is absolutely unnecessary to section off your graph paper. It's a tool that I like to use to help break my graph paper up into pieces to make sure that I don't accidentally graph like beyond that. And if I was doing an answer key, maybe I would erase this dashed line at the end of my problem, or just write it like really lightly so you couldn't see it. But for the example, I'm going to put it in nice and bold. The second part of my piecewise function, which is a horizontal line, y equals 5, is only going to get graphed from -1 to 2, and it actually includes those endpoints. So that is the second place that I'm going to break my graph up. It's already broken up at -1, so now I just have to break it up at 2. My second horizontal line only gets graphed in the middle of this graph paper between my two sets or my set of dashed red lines. And then finally, the parabola x squared minus 6 is only going to be graphed for x values that are greater than 2 on the graph paper, and I already have that sectioned off. So any part of the graph paper to the right of this dashed line, that's where I'm allowed to graph my parabola. Now the other thing that I have to make sure that I'm careful with, and I like to do this ahead of time, is whether or not we are including the ends of each interval in our domain or not. So before I even start trying to get an XY table, I will draw whether my graph contains the point or not, like right above the inequality symbol. So x is less than -1 means it doesn't include the point because it doesn't have the little equals under the inequality symbol, and that's going to end up being an open circle. And then these two inequality symbols have the equal sign underneath, so that means that they contain those endpoints. So at the end of either side of my second graph, I'm going to have closed circles. And then finally, I have the greater than symbol here in my last domain, and that means that you actually don't include the two in that domain, so open circle for that. And then we're ready to graph. Now there are many methods that you can use to graph each equation, and being that I teach math, I know the shortcuts and I know how to graph them faster than an XY table. But for the example, I'm just going to stick to an XY table just to make things as basic and easy as possible. I can graph the equation of my line x plus 1 without an XY table and do slope-intercept technique. I can graph my equation of y equals 5 using the fact that it makes a horizontal line and just move up 5 on the y-axis and draw a line straight across. And then I can also graph my parabola very quickly, knowing that this graph right here is a basic x squared equation transformed down 6 spaces or 6 units, and I can graph that pretty fast without even making an XY table. However, if you aren't that familiar with graphing techniques for lines and parabolas and other types of graphs, then you're just going to make an XY table for each. So let's start with y equals x plus 1, f of x equals x plus 1, and I know that I'm supposed to be plugging in values for ordered pairs that are less than -1. So I'm going to make a little mini XY table. And then I'm going to put in, let's see, what's to the left of -1? Maybe -3, maybe -2. And I'm going to do something that I'm probably not supposed to do. I'm actually going to use my -1, which is an illegal point. And I'm going to find out just the location of where -1 would be. And then instead of filling in the dot, since it is a point that is not in that domain, I'm just going to make it an open circle. But it gets me right up close to that line as possible if I actually use the point that I'm not supposed to use. So let's go ahead and quickly plug into our equation or substitute our values in. So when I let x equal -3 and you add 1, you get -2. And when I let x equal -2 and I add 1, I get -1. And then finally my legal point, when x is -1 and add 1, I get 0. So technically this point doesn't count. It is an open circle, but I'm using it just as a guide to know where I should be at that open circle. Okay, so we're going to go back 3 and down 2 and put a dot, and then back 2, down 1 and put a dot, and then back 1, up and down 0, and don't put a dot. We're going to put that open circle. That's my illegal point that I wasn't supposed to use, but I used it anyway. Now, if you don't want to actually use the -1 because you're not really supposed to, you could use maybe -1.1 or something else, but I don't really feel like dealing with decimals, so that's how I do it. All right, so that's the first equation done. Now we're moving on to the second part of our piecewise, and that's y equal 5, and that is a horizontal line. And this is really easy peasy, just real quick. Put a dot at 5, draw it straight across, but I'm just going to show you the ordered pairs anyway. I'm going to use -1, and then I'm going to use 2, because the ordered pairs are supposed to be from -1 to 2. And when you draw a line, you really only need 2 points, so I think that's good enough for me. And then when I try to plug a -1 into my equation of y equals 5, there's nowhere to put that x value and the answer's already calculated. The y value is still just 5. You don't even have a place to put the x in. So when x is 2, I don't have anywhere to put it. Calculate, calculated, it's already calculated. Your y value is 5. So graphing this ordered pair style, you're -1, up 5, and then you're over 2, up 5, and then connect to make a horizontal line. And these guys here on the ends are included in that interval. So I want to show that by putting some nice closed circles. And that is done for the second equation. And then finally we have one more equation. It's my parabola, and that is y equals x squared -6, and then I'm going to make a little xy table. And then quadratics get fairly large quickly, those y values, so you're probably not going to be able to put that many points on this graph. And we're really technically not supposed to use a 2 because our function wants x values, or the domain of that part of our piecewise function wants x values that are greater than 2, but I'm still going to use it anyway. And then I'm just going to make sure that I put an open circle at that location. So we'll use 2 and 3. And I know ahead of time that if I use 4 when I try to graph it, it's going to be off the graph paper. But we'll just figure out what the ordered pair is anyway. Okay, so we have 2 squared minus 6, and that comes out to be 4 minus 6, which is negative 2. Then we've got 3 squared, which is 9, minus 6 is 3. And then we have 4 squared is 16, minus 6 is 10. And I'm definitely off the graph with the last ordered pair. Don't forget 2, negative 2 is really illegal, but I'm going to plot that location anyway with an open circle. So over 2 down to open circle, and then over 3 up 1, 2, 3 closed circle. And then if we plotted the next point, it would be over 4 up 10, and you'd be somewhere up here. And I've tried this a bunch of times today throughout the day, doing these examples in class, and I'm just not doing that successful or doing that well with it. So I'm going to stop right there and try to make this curved so it looks like part of a parabola, and then that's it. And that's the end of our problem. You could, if you wanted to, erase the dashed lines. I just leave them in there, or I don't really draw them that dark in the first place. I wouldn't mind them being in like a homework problem. I would just go ahead and leave those right in there. And that's what your graph should look like. And just real quick before I stop this example, technically if you were allowed to use the entire graph paper, your line would keep going like that. Technically, if you were allowed to use the entire graph paper and you didn't have domain restrictions, that horizontal line normally gets graphed all the way across. And then your parabola would come all the way down to there, and then would come up. I'm not going to do a good job. I'm just going to do a sketch quick. Will come up on the other side. That's a pretty bad sketch, but. And then if I were to graph each one of these equations like you normally would separately, they would be crisscrossing all over the place, and they would be failing the vertical line test, and you would have x repeats in your domain. So this isn't a piecewise function right here. It's not a function at all. The way I just boogered that up is actually 3 equations all slapped on one piece of graph paper. In order for it to be piecewise, you are only graphing each function on a certain portion of that domain or x-axis. And then you can see as I get rid of all of the lines that I just drew in there, I passed the vertical line test in every single location here. There is not one part of my graph here that I draw a vertical line in, and I actually use 2 ordered pairs that share the same x value. Like, even though my graph's pretty sloppy over here, you're probably saying that I do over there, but technically if I graph this better, you wouldn't.